Si, senor.
Si, senor. All right. And how did that go?
Wasn't too bad. I only cried once, so.
And I didn't get a picture. That's terrible. Okay. So for our homework, and let me open up the keynote here. So implement SendMessage such that it allows us to get the value from a class for one of its fields. Or so in this case, I'm saying, well, here, let's just review. We embedded a function into our class. So let's go and review what our classes look like. So right now, a class has a base class. It has a list of field names, a list of field values, a list of method names, and a list of method values. So just like in Java, what's a class? A class has a parent class and has a collection of fields and methods. Okay, and we're kind of handling our constructor as this idea of creating the pairs for our scope. So the constructor effectively loads the environment, the global environment of our object together. So we get this global environment thing. So when we build a class, have a function for creating a pairs for scope, which takes in a list of names and a list of values and effectively merges those together. So that should look, if you remember, this was something from an earlier, like in that first batch, the first couple of weeks of class when we were writing these like toy functions to get used to, what's the name of this language? Scheme. To get used to the scheme language. One of them was to effectively take two lists and merge them together. I don't remember what it was ultimately called, but it was something like that. The merge question was the merge sort thing, but there was one that took two lists and merged them into two lists, a list of two lists. All right, so this guy's a function, and then our global environment will be the appending of our list of field names and list of methods with a list of field values and list of method values. So this will give us one global environment that has all of our fields and their values, as well as all of our method names and their values. All right, so it'll be inside of this global environment that we will need to look up the value associated with a message. All right, so the idea here is that when I send a message, I am effectively telling the class to look in your global environment for the value associated with this message, and then apply that value to these parameters. That's what we're effectively doing. So if we come back here, what does send message do? Sends a message to an instance of a class, which asks the class to look up the message as if it is a variable name from within its global environment and return its value. The value can then be applied to any parameters that are passed. So the idea is if we asked the, if we sent the message for a field name, we wouldn't give it any parameters. If we sent the message for a function name, a method name, we would probably give it parameters, assuming that method took some parameters. Okay, so that's effectively what SendMessage is going to do. All right, so we have our empty object, which is our which is kind of our parent class. And this is, I kind of mentioned that you need to have something there for doing this. So the idea here is if I'm looking, if we have a person and I'm sending a message to this person, like here, I'm sending message to P2. What message? Get value. And the value, the parameter I'm sending it is F name, and I expect it to give me a Dave. Well, when I send that to P2, he's going to check his own global environment first. If he doesn't find the message I'm looking for, it's then going to bounce up a level to the parent, where the parent has his own global environment. We have another chance to look it up. All right, so this is a class, this is a class, this is just a specialized class. But what we're looking at here is we have two different global environments at play here. And the way I have it designed right now is that it's the parent object. The parent object has a function that allows you to get a value given the name of a field. So that's something we embedded inside of our parent object. So if I look at empty object here, empty object has no parent. It has no list of field names, no list of field values. It does have one method name called get value. That's the guy we're supposed to make work for the homework here. And then it has one value associated with this. That is, we are taking a lambda, passing in a variable name, and this guy's job is to look up in the global environment for this particular object what the value of that is. All right, so this is where the logic for our homework needs to go. So we need to first write this function. This is the function that looks up this variable name in this guy's global environment. Okay, and where does this guy get a global environment? He gets it from his class. Okay, so when we build this class, we're going to be stuck with, I think I showed what the class looks like on the slide. I can run it again otherwise. Yeah, so it's going to look something like this. So the first part of my class is going to have, here's my, well, so it's going to have the word class, then it's going to have the list that is the who the parent is. Then it's going to have the list of name value pairs that are in there. That's his global environment. So we're going to need to first write an extractor that pulls the top level global environment out of a class. All right, so if I have a class like we started writing some constructors here. So if I have a class here, and this, I'm asking who the parent is. Let me take out, well, I can't run this yet. So let's just do it in the slides. Bring this onto its own slide. All right, so if I have something that looks like this, and I'm going to break this up a little bit. So I have this guy is a class whose parent class is this guy. So when I talk about his parent class, what am I talking about? A class itself is effectively an environment. That's what that guy is, right? Well, that's what this guy is. So a class has the word class. It has a who's the parent. So in this case, this whole guy right here is the parent of this larger class. And then we have the environment for a class. So we need to have the ability to extract an environment from a class. A class has three pieces: the word class, the parent, and then the global environment of that class. All right, so let's write that piece first. So we're going to define class. We already got class to super, so that gets us the car of the cooter of the class. So that gets us this piece right here. This is our parent. All right, now we need to get our environment. We called it list of fields. This guy actually, list of fields, I guess, this is something we must have written at the beginning, because we can really update this now, because the CADDR is the class's environment. So that'll be the environment associated with a particular class. So if I have this class right here and I say, give me your environment, it's going to give me this piece, the CADDR of that list. All right. And that guy will be an environment that we want to search within. And it is a list of two lists to ultimately give you an answer. So we need to write a function that, given something that looks like this, find out if there is a variable in there. We used to call this apply environment, right? That's what we had in our other, this guy takes in a list of two lists. So here, we'll write this up top here. So we'll call this guy define. These are my constructors. We'll write it here. Define apply env will be a lambda. Make this guy a little bit bigger. Will be a lambda that takes in a environment, and it takes in a name, and it tries to find the name in that environment. Now remember, this environment is a list of two lists. So we're going to have a cond null env. We'll go ahead and return false for right now. We'll decide if we want to change that to something else. Is it false like that or false like that? That'll scream at us. They probably both work. So null env, will have it return false right now. Otherwise, we must have a real thing in there. If we have a real thing in there, we need to check the car to see if it is the name that we're looking for. So we'll get the car of env, which is a to list. We'll get the car of that to list, which should be the name. And we're going to ask, is that name equal to the name we're looking for? If it is, we want to return the catter of the car of env. Car of env is my to list. The catter of that would be the value associated with. So we could have also called it the cadar. This is the cadar of env, but I think that starts becoming a little bit, creepier. That gets me a to list. This gets me the value associated with that to list. All right. Otherwise, I'll go ahead and call apply env, passing it the cooter of env and the same name. All right, so that should be apply env. I pass it an environment, I pass it the thing I'm looking for. It returns the value of it, or false if it's not there. Okay. So what we want to do is, when we write SendMessage is ultimately going to call apply env on the most local environment, passing the message in for the name of the thing we're looking for. Okay, because that's what we're saying. The message we're sending to a class is the name of the variable that we want to get out of that class. The name of the field or method whose value we want to get out of that class. All right, so let's write this piece in here. So if I have an empty object, this empty object is going to have his job right here, the job of get value will be a lambda that takes in a variable name, but it also needs to take in an environment in which we need to look up that variable name. Now, I can pass that here, or I need to otherwise have access to that environment. So for right now, we're going to leave it like this. And we're going to assume in here, we're going to have an environment, and we'll decide how we're ultimately going to get access to that environment later. So what will this guy do? He's going to go ahead. You know what? Actually, we'll need, I think we are going to need to pass in the environment in which we're looking for here, because this is the top level object. So we're going to look inside of this environment for this variable, and what we're going to do is this guy is going to boil down to apply env, and I'm going to pass it the environment and the var name. So that's what get value will do. This function, if I give it an environment and I give it a variable name, it will return for me the value of that guy, or false if it's not found. Okay. So remember, we have two steps here, because if we're going to ultimately go back a couple of slides here, if I send the get value and I pass it f name here, ultimately, this guy is also going to need to know the environment in which he's, so we might actually change this, but he needs to know the environment in which he's looking. And whenever we have an object, we're going to look in this environment first. Then we're going to look in this environment. Now, for send message here, we have two different steps, though. I'm sending the message get value. I need to look this guy up first. So I'm going to look for him here first, the most local. I will not find him here. Then I'm not going to give up. I'm going to check here. I'm going to find him in the parent, the super object. And this is going to be a lambda. But once I have that, once I've retrieved the value of get value, and I recognize that that guy is a lambda, I can then apply that function to this parameter. All right. Now, I'm going to pass it another value, though. And we're going to kind of see how this works from, if you remember in Python, the way I'm going to model it here is kind of like how Python deals with classes, where a class brings itself in. Okay, an object, a method asks for itself, not necessarily the environment, but itself. So if you remember in Python, if we're inside of a class, every method we write in that class takes as a parameter an instance of itself. That way it can get values from itself, like its global environment. Okay, so with that in mind, I'll update this, and any methods that I have stored inside of a object will take in whatever values it needs, but it always has to take in a pointer to itself. And that we're modeling our object-oriented language kind of after Python's object-oriented language. If you did this differently, that's fine, but this is kind of a means to explain why Python works the way it works for passing a pointer to itself around. All right, so get value is going to be a lambda that takes in two parameters. One of them is provided by the end user. The other one has to be wrapped in automatically somehow. And we'll see how that connection is going to happen. And what do? We get the environment from a class, and we just wrote that piece, class 2env. So we'll call class 2env passing itself. This is the environment in which we are looking for this variable name. Okay. Keep in mind here that self can change. The value of get value is this lambda. It doesn't imply who self is at this point in time. I just have a lambda that I can call with whatever two parameters I want. One of them should be an instance of a class. So presumably, once I've looked up get value from here, and I'm ready to send that guy fname. Fname is a value I need to look up. I need to get the value of fname. And I'm going to look for this. This is a variable name, not a literal. So I'm going to first look it up in my most local to get the value of that guy. I'll pass it this guy in for self. I'll pass this guy's environment in for self. And it will apply that and hopefully get me the name of Dave. If it doesn't, it'll give me a false. We're again presuming the value is never going to be false stored with a variable. We can debate that later. But if not, if I don't find it here, then what it'll do, it'll say, okay, I still have another place to look at. I'll ask for my parent super, and I'll call get value with super. Remember, I've already looked up the value of get value. Get value is this lambda that's sitting over here randomly. Here, I'll just, where did it go? So this is lambda. So this is the value of get value. I've already looked that up. That's first pass. I have a function that I now need to apply to some parameters. Now I'm going to initially apply it to the parameter fname with my most local object for self. So I'll pass in P2 initially, and I'll look for fname inside of P2. So P2 will be self. Fname will be the variable name. And I'll call apply env on self's environment with that variable name. If this returns false, then I'm done. If this doesn't return false, if this returns false, then I didn't find it here. I need to ask, will I find it someplace else? And where is the next place I can look? So if I searched here and I didn't find it here, the next place I can look is this dude's parent. And I can keep doing that as long as what is true. As long as I run into somebody whose parent is not the list no parent. So I can keep checking, starting with a base class until I find somebody who doesn't have a parent. And then I've run out of places to look. Okay, so get value will take in two pieces of information. It'll try to call apply env on this guy. So I'm going to go ahead and create a lambda this. I'm going to kick this down a line. And we're going to go ahead. I'm going to do this inside of a let. So I'm going to say let get the end of that guy there. We're going to say let answer be this. All right. And we're going to say that's the end of our name value pairs there for our let. It's fine for the moment. And then we're going to ask a question about our answer. We're going to say if equal answer false. If I didn't find it in the most local place, then I need to search in the next most global place, the next level up. So if it's equal to answer and class to super, kick this down the line here, of self. You know what? I'm actually going to give myself that value up here. I'm going to say parent is equal to class to super of self. That way I already have that value. So if answer is false and not equal parent, and we've decided that this guy would be called no parent. If both of those are true, if the answer I'm looking at is false and my parent is not no parent, that means I do have another place to check. So where do I check? I call get value. So I call this function himself on this function on the parent along with the same variable name. Okay, so the question is how do I pull that off? How do I call this function that doesn't currently have a name? Can't I build it into my letrec and have a function that I can call recursively from within? We're going to build a letrec here. This guy will keep track of that piece of information. He'll keep track of this piece of information. Now, he's also going to have a lambda in there. So we're going to call this guy check parent. And check parent will be a lambda that takes in. So we need to have a way of starting it. So that's where we got our original get value. The issue here is that when I passed it in, when I called this, I no longer have access to the name associated with this. So I need to get the name associated with this. And I can build it in here as my own letrec. That way it has a name like check parent. So we'll say check parent is going to be a lambda that is going to take in I can call it self there. It will be a more local copy. But I'm actually just going to, I'm going to call it the parent. And I'm going to call it var name. And this guy is going to be written in terms of these pieces. So if both of these are true, then I need to go ahead and I need to call. Let's see. I really need another let inside of here. I'm going to steal these two. And then this guy is going to have a let. Where I'll be getting the apply NV of the parent. And I'll be calling, asking whether I'll go ahead and get that guy's parent as well. So now I have those two things are the local environment for this lambda that lives inside of this let rec. So this guy can now ask the question, if both of these things are true, then I want to call check parent. Can I not get inside there? Okay, that's fine. Then I want to go ahead and call check parent. And check parent requires me to give it a parent and a lambda. The parent will be parent. And the var name will be the var name that was passed in. That's if that is true. So if I didn't find it yet, and I don't have, and I'm not at the top of the line. So if I didn't find it in the most local object and my guy has a parent, then let's check the parent. So that's what we've named this function here. This is check parent, which is a lambda that takes in a parent and a variable name, and it remembers the current answer of looking up that variable in the parent, as well as who that parent's parent is in case we're going to need it. And if we didn't find the answer and we don't have a parent, you know what? We can actually do it because there's really three different things that can be happening here, right? We can either have found the answer, or we didn't find the answer, but we have another place to look, or we've run out of places to look. So rather than an if here, why don't we write this as a cond? And we'll say, if both of those things are true, then check the parent. We'll have another cond that'll just say not equal answer false. So if answer is something other than false, that means we did find it, and we'll just boil down to answer. That means we found it, boil down the answer. Otherwise, if it is false and we have a parent, check the parent. Otherwise, we can probably just boil down to false and say that's our version of I didn't find this anywhere. All right, so get value, this top level thing is going to allow us to take in a class and the variable name we're searching for, and it will go through the process of checking that class on up the hierarchy until we find it or run out of places to look. All right, that's what get value there will do. So what will SendMessage do? SendMessage should take in an initial class, should take in the thing that we need to find. So this is the original thing we're looking up. And then we'll actually pass this guy to the result of this. So let's just focus on this first part first. So I need to take in a class and I need to take in a value or take in a message, which in this case is the word get value. And I need to search that class for that guy. So SendMessage is going to be a lambda that's going to take in a, let's call this guy class instance, and a message. And I'll go ahead and take in my list of params now as well. We won't use that the first pass through here. We'll use that only when we go to actually, we're going to get our lambda first. And then once we have the lambda, we'll apply it to those parameters. Okay. So I need to look in this class for this message. And we happen to know that in this case, the message we're going to be sending this guy is the get value message. Find me the function associated with get value, either in this class instance or one of his parents. Okay. Now, how do we look for a value inside of a class? I need to check that class's, I need to check that particular class's environment. So I'm looking for this message in that class's environment. Now, how do I get to this class's environment? Well, I have a class 2env. So I'll just go ahead and give myself a let here just so I have something to work with. So we'll call this guy env class to env class instance. Something like that. Got an E on it. So that'll get me the environment associated with this guy. Now we're going to see that this looks pretty similar to what we have here for get value. Get value is almost going to be a repeat of what we're doing here, but we haven't gotten to get value. So this guy allows us to extract a lambda. This lambda happens to allow me to receive a field name and look for it in the same kind of environment. That's why these guys look very, very, very similar, well, or will look very similar. The difference is this guy is trapped inside of an environment where this guy is something that I can call out here. Hence the reason for the duplication of code. We could write this guy as a generic function and then call him from two different places. And maybe we'll do that at the end, but let's just see how this is working. So again, regardless of how you ended up doing this, the model we're trying to mimic here is the Python model of passing around itself. Okay, so while this guy might seem overly complex initially, we have to make the assumption that in an object-oriented language, those primitives that allow us to build complex objects on top of that must have some kind of special sauce for allowing us to pull that off, right? They got to be something special in order for it to have that level of talent, let's say. All right, so when I send a message, I'm sending it to a class instance. Here's the message I'm sending. So I'm going to go ahead and grab the environment that I have available to me from this class. Now I'm also going to, so this is kind of where we mimic what we have up here. In fact, do I want to just steal that? Let's walk through it because I want to change my variable names for this guy. Plus, it'll just be like we're reviewing this anyways. Okay, so for send message, we want to go ahead and get our environment. How do we get our environment? By extracting it from our class instance. Great. Okay, now what do we do with that environment? Well, we want to try to get our answer. So we're going to go ahead and change this guy to a let star. And we'll say answer is equal to, and what do we call this guy? Apply env. I'll pass it env. Remember, a let star allows us to use previously defined variables. That's why we changed this to a let star. So answer, apply env in the environment, and we're looking for that message. Okay. Now, we have either found it. Actually, let's go ahead and get the parent too. The parent here, and we could have gotten it in the other order, will be class to super. Of class instance. All right, so now we want to have a cond. Now we've either found our answer. So if I found my answer, then what do I do with it? We're going to leave that part blank for a second here. Okay, so we'll say if not equal answer false, then we want to do something. And what do we want to do? I'm going to put a little question mark there for right now. Okay, that's if we did find the message we're looking for. Otherwise, if equal answer false and not equal parent, no parent, if both of those things are true, if I didn't find it yet, but I have a parent who might have it, then I'll call send message, passing it my parent as the class I'm looking for. Class instance is no longer itself, it's now its parent. Passing it the same message and passing it the list of params. All right, now remember, we're not doing anything with list of params yet. List of params is going to have its own complexities here because that guy needs to be resolved as well. Okay, we need to get that those values from there. So we'll, this isn't correct yet that we're passing this along. We really need to get these guys resolved before we can, because presumably these guys are either literals or they're fields found inside of one of my environments. By me passing it along to the parent here, I've possibly lost out of my way to find these. Okay, but for right now, let's just assume that these guys are all, I don't know, we'll just say they're literals for right now, which would match what we were, well, just leave it at that for right now. We'll just assume they're literals for the second. All right, so if the answer was false and I have another place to look, what am I going to do? I'm going to send the message to that other place. Same message, same list of parameters. which might be a problem. We'll, like I said, we'll get back to that. Okay. Else, I must be looking at the end of the road, and there is no this message can't be sent. There's no respondent to this message, so we can decide what we wanted to say. We can do something like display message not. I could probably just do it as a string. Message not found, something like that. Okay, so that's what SendMessage will be for that guy. Now, for right now, when I finally find it, what I'm going to do, I put a little question mark here. What I'm going to do is I'm just going to boil down to answer for the moment, which should be when I finally find the, when I call this guy with my send message, P1 get value, the value of get value should be a lambda. That's why I expect to get out of there. So when I call send message, passing it P1 as my class instance, passing it get value, and this guy is going to be a the name of a variable, okay, which might be, in this case, I know it's associated with a lambda. So I'm going to pass it the name of the variable and then some other stuff that we're not doing anything with yet. And I'm going to search through here, and I'm going to grab the environment from this guy. I'm going to look up my message in that environment, trying to find a match, which I know I won't find one in P1, because we know that get value is actually stored in the base class. Okay, so it will not find it here, but then we'll ask if the answer was false and I have a parent. Does P1 have a parent? They do. P1's parent is the empty object, which doesn't have a parent himself, but person has a parent empty object, which is not equal to no parent. And since that's the case, I will get into this and what will I do? I will send the identical message to that empty object. And that empty object looks like this, and he does have something called get value. So he'll find it and boil down to that lambda. Let's see, I cut it off too early, I'm guessing. Oh, this is my let rec for check parent. This guy's not done yet. All right, so there's the end of the let rec. I have to have a body for this guy. So the body for should just be check parent, because that's the value associated with this guy. So that's my environment in here that has a check parent, and this is going to be a lambda. No, it's okay. I don't need to call it. I'll just return it. So this guy will boil down to that lambda. That's the value of that guy. So remember, when I build an object, you have a list of field names, list of field values, list of method names, list of method values. So the method value associated with this guy is a lambda. That does all those things, and ultimately the value will be that lambda. So that's what should boil down from that check parent. Let's start. I'll do the same thing here. That's the end of that. That's this end of that one. That's the wrong end there. Okay. I called it send message like this. Oh, I need to put my extractors higher up in my code so it knows about these. All right, CADDR expects. So I passed it and I just got the list no parent. So I'm trying to get the environment for somebody that doesn't have a parent. So it has to be happening here. Let's trace that down. Send message P1. P1 looks like this. I'll go ahead and print out P1 just so we have it down here. Okay. And then I'm going to say I'm sending the message get value and F name. F name doesn't matter in this case. I'm not using it. So this is P1. This is get value. I'm going to let my environment equal get environment from P1. Let's make sure get environment, since we wrote it last time. The car of the coder. So there's the third element of a class. That's correct. So it'll get me the environment. This will get me the answer when checking that environment. This will get me the parent, which might be no parent. So if not equal answer, this is where I'm going to ultimately boil down my lambda. Otherwise, if both of these are true, if it's equal to false and the parent is not equal to no parent, I wonder if it doesn't like me. This would be class to super, which is going to give me an entire class. So when I get the entire class that is no parent, it's still going to be a class. So I need to make sure I can't just say no parent here. I need to use my extractor to get the super. I'm lost. There it is. Like that. So when I get the parent of parent, if this guy has no parent, then I know that, you know what, that can't be right.
So Bracker and I got the same error. We solved it in a different way, but we kind of got the same error. And we didn't realize, we couldn't figure out why. But whenever we took the car of the object, the error went away.
Okay, so that was what I was about to get into. So I don't need to do this here, but the issue is that I can't compare parent here. Parent here should be this last time through something that looks like this. But what I guess I can't do is I can't say equal no parent to no parent. Can I compare the contents of two lists? Because if I get the parent from this, let's see what it's called. Is it a list? Here's a class, and the CADR will be this list containing no parent. But when I ask for...
Is it the list that's containing the list, no parent?
No, because it'll be the car of the cooter. So this is the list whose car is this list. So that's what it's actually returning, is the list no parent. Here, we can test this pretty easily by, instead of calling SendMessage here, let's just print out parent. So here's the parent of that guy. All right, so that's showing the correct parent. And then I was, go back in here, sending a message to that parent. So then I was getting the environment from that parent. That's fine. And then I was getting the parent of that, which would give me, so the parent of this guy is that list. So I'm getting past this. I did return a lowercase f, right? Yeah. Let's make sure that's what's coming out of there, is that lowercase f. So I'm just going to change this to answer for a second here. Okay, that gives me a false. Oh, and we know that's the case because it's I checked against it there. Parent equal to no parent. We've seen parent the first time. Parent the second time is going to be this piece. So now if I try to get the environment, well, no, I'll never do that, because I will have the environment from this guy, which is this stuff over here, of the answer, which should actually be the real thing. And then I'll have my parent, which this guy does have a parent. That's his parent. We just can't go any deeper than that. So if the answer is not equal to false, it's fine. Did I name it get value? Am I spelling it correctly? Okay, hold on. That is, no, we're good. The problem is the lambda. I'm trying to return this whole lambda. But that is what I want. So it wants me to pass it. I need to call this function correctly. I need to pass it self and var name. So that's from which thing? CADDR. That gets the environment. That's this piece right here. I'm never actually calling that. Well, I guess I am down here. Here. Just for the sake of argument right now, I'm just going to boil down to 5 right there. We'll have this, crazy let rec that never gets used is what it's going to be. Okay, so it's not that call. How are we getting? See, it's happening when I'm trying to get the environment from something that is no parent. The CADDR is the environment. So that's this guy. So it has to be happening from that line or this line. So somewhere in here, I'm calling when I call check parent here, this is being allowed to get through. So if it's equal to false and it's not, and parent is not equal to, that's this parent, is not equal to no parent. If both of those are true, then call check parent on that parent. Here, I'm going to try to just print out parent here. So it's not happening there. Where is it happening? Well, I guess it has to be happening here then. But how is the parent ending up? So I'm never actually calling it. How does the debugger work in here?
I don't think it really does.
Well, that's good. So I'll step over that. Actually, let me start over. All right, so we'll step over this line. Oh, can I step out? Step out, step out. All right, so it died right here. Send message, class instance. So this is when I'm trying to get the class to the environment of class instance. It's doing that on a no parent. How am I ever getting into send message? I'm originally passing it P1, which is a person, and a person is an empty object, so he does have a parent, so that should be fine. Let's just check something here. Let's say class to env. And that should give me just the environment associated with that guy, which it does. Okay, so that looks okay. Class to super. Should give me that guy. And what if I call class to super on that guy? Class to super should give me the no parent as a list. And then the error message we're getting is when I would call class to env on something that looks like this. This should duplicate that error message. Correct, it does. So that error message is when I'm trying to get the class environment from, but I didn't think I was ever passing it that. I'm gonna breakpoint. Can I do a breakpoint somewhere? Of course not. All right, so we're gonna walk this. Just give me a, what does this guy look like over here? So it shows me it's currently, class instance is currently no parent. Message is currently get value and list of parameters. So how did this guy get to be no parent? That's what I want to see. Need to get it to that second call. And I know we're just about out of time. It's got to be like a stupid little mistake. All right, so there's our second call. We're just about there. All right, so now we're getting into send message. Where class instance is a bunch of stuff. So that looks good. And we have the actual environment for that guy over here. And we're currently looking for the message get value, so we're not going to find it inside of the answer is false. Good. Step over that. Parent should be a class, a real class. Good. Then we do our con stuff. So now we're in the and. That should all be true. So now we should be calling send message again. Passing it the class that has no parent, which is fine, still class. Get value, so we're still good there. All right, and here's our environment that has the get value in it. That looks good. Oh, it didn't find get value. And then who's the parent? No parent. Good. That all looks good, except answer is not what I expected answer to be. Okay. Let's see where it actually crashes then. So we're not going to get in there. In the end, is answer equal to false? Yes, it is. But is parent, which is equal to no parent, is it true that that is not equal to no parent? That can't be true. No. How is that true? All right, well, I'm going to look at this. We have to figure out why this isn't true. Maybe it is something like you were saying, Noah, where you had to take the car of it or something.
Yeah, that works for Big Mike and I.
Like it couldn't, because parent is definitely equal to no parent.
I seriously got stuck in an error like this for like 6 hours.
The car solution also worked for me. I also had to do that.
That is stupid. I should be able to compare two lists. But the problem is that no parent like that is different than a quoted no parent. Is that it? Do I have to quote this guy? Yeah, I'll play with it, but that is, I don't get why I can't compare two lists with each other for their content.
I could be wrong, but wasn't the little quote mark, doesn't that mean that it's a list? So then wouldn't the
No, quote means that it's don't process it. Like don't treat it as a function.
oh.
So So like when I have quote get value like this, it doesn't try to run the get value function. All right. Well, it's got to be something stupid, some misunderstanding I'm having on how to compare the contents of two lists. That still doesn't answer why we couldn't find why my apply INV failed. Because really, this should be working anyways, because it shouldn't actually be getting to that point where it didn't find it. That's kind of a bad assumption. We should have an assumption where a variable environment might not have your answer, and if it doesn't, you should have a way of stopping. I guess we do. We just crash right now, but that still doesn't explain why it didn't find the value of get value, which should have been a lambda. So I'll look at it. I'll post on Slack what the issue is, because I don't like the explanation of I just did a car and it worked. I mean, I get it. I get that that might have worked, but I want to know why it worked. So I'll get to the bottom of that. And then I guess I'll grade the assignment really easily, because if I can't solve this in an hour and 15 minutes pretty trivially, I don't expect you to do it in a couple of days. So so let's just look for the punchline of why the comparison didn't work. It's probably something stupid, but it'll be instructive as to how Scheme works that way. All right, so no homework over break. I'll see everybody on Tuesday. Remember, next week we'll be all online next week. Students are, I don't know if they're encouraged or whatever, but you don't have to come back to campus, since all your classes will be offered online at the very least starting next week. Many still might be face-to-face. It depends on the class. But final exams are all online, and the way I'm going to do the final is I'll have the final exam up by about midnight Sunday, let's say, of finals week, and then you'll have the entire week to do it at some point. So you don't have to take it at the normal final time. Just get it in by midnight the Friday of finals week. But we'll talk about that in more detail next week. Sound good?
Are we going to do a review at all?
Yeah, we'll go through the stuff that I think you should focus on for the final on Tuesday or Thursday next week. Probably Thursday.
Awesome. Thank you.
Yep. All right. Well, other than questions about what I'm missing here, any other questions, comments, or concerns?
Nope.
All right. Well, I have my homework over break then to figure out why. I hope it's something stupid and not a misunderstanding or something I taught you wrong that cost you 5 or 6 hours. But I guess we'll find out. It is what it is at this point. All right. I will see everybody on Tuesday. Have a safe break.
See you, Littman. Have a safe break.
Thank you. Have a good break.
Yep. Take care.